This video is on key features of a function. We're doing example 2. The graph below is used to model the suspension cables between the two towers from the Golden Gate Bridge in San Francisco, California. Architects and engineers need functions to model the design of the bridge to make sure it will provide the proper support and stability. The graph displays the height of the cables based on a given distance from the left tower. So our actual cable is in a U-shaped, and it is between the two towers so that it can hold up the bridge. This is the actual graph that could represent this shape right here. So we're going to identify the independent and dependent variables. So independent and dependent. The independent variable is the one that you can logically change, and the dependent variable is the one that is affected because you change the independent. So we can change quite easily the distance from the left tower. The dependent would be the height from the bridge depends on how far away it is from the tower. So the independent variable would be the distance from the left tower, that x-axis. The distance from the left tower. While the dependent is the height of the cable from the bridge surface. So now we're going to estimate the height of the cable when it is 150 feet from the left tower. So 150 feet from the left tower. That is the x-axis. Distance from the left tower. If we are at 150 feet from the left tower, I'm going to go up until I get to the function. And then I'm going to go left until I reach the y-axis. It's not an exact amount, but I can see that it's somewhere between maybe 40 and 42 feet. So approximately 40 to 42 feet above the bridge surface. And it does say to estimate, so this is not an exact answer, because I know that up here would be 60, and it's really close to 40, so I'm going between 40 to 42 feet. The next question says to estimate the distance from the left tower when the cable is 100 feet above the bridge surface. So when we have the 100 feet above the bridge surface, that is the y-axis. So I'm going to go to 100 on the y-axis. So we have 20, 40, 60, 80, 100. I'm going to draw my line, and it hits here, but it actually hits twice. So I'm actually going to continue drawing my line. It happens twice. So this is twice at that height. I'm going to find both of those measurements. So I'm going to, at this first one, at the 100 feet, I'm going to draw down. And then that's at about 50 feet. It's not exact. And let's find the other one. So over here at this dot, I'm going to draw down. And it's at about 450 feet, roughly. And 450 feet from the left tower. Always put it back into context. So at about 50 feet and 450 feet from the left tower, it's 100 feet above the bridge surface. Now it says to estimate the y-intercept and explain its meaning in the context of the problem. So again, the y-intercept is where it is touching the y-axis. That is a little bit above 140. It looks to be about halfway between 140 and 160. So we can say that the y-intercept is about 150 feet. So then in the context of the problem, we can say at 0 feet from the left tower, the height of the cable is 150 feet from the bridge surface. Find when the height of the cable is increasing. So we want to find the interval of increasing. So again, we want to go from the left to right. As it's going from left to right, when does our cable start going up? So as I follow the shape, the graph, from the starting point, it's going down. It's going to keep going down, down, down. Then it comes to a stopping point, and then it starts going up. So it actually starts going up from this point onward. But then it stops again, because it does, if we look at the actual shape of it, it does stop, and then it comes back down and goes back up. So we can see that the height of the cable is increasing from that first point where it started to increase was right here. That's the x value of 250. So we would say from 250 feet to when does it stop? And then it has to stop here because that's the right tower. It stops at the 500 feet. So to 500 feet from the left tower. Now, to write this in an interval itself, because we have a starting and a stopping point, we would write our inequality as we'd put our starting point, 250. We have our x's in the middle because all of the x's are increasing between 250 and 500. So in order to make this into an actual interval, we need our inequalities. Well, at 250, that's your smallest value. So all of the x's are increasing after the 250. But then it stops at the 500, so the 500 is the last value that it increases at. So we would say that the x values are underneath the 500. So this is saying that all of the x values are between 250 and 500. This number can represent 251, 270, 290, 350, 400, 499, and then 500 because it stops at 500. But that is why we have the inequality facing this way, because all the x values are bigger, because this means that the x values are bigger than 250, but the x values are smaller than the 500, and that's what's happening here. At these x values, my graph is increasing. It's increasing until I get to 500. So when I want to find the height of the cable is decreasing, I again start from the beginning. And as I follow my graph, when is it going down? So it's actually starting here, and it is going down, 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 until it gets to that turning point here. So it starts at that 0, the x value of 0, and it keeps going down until you get to the x value of 250. Because that's the 250 is when it starts to increase. So we can say that the height of the cable is decreasing from 0 feet, because that's the beginning of it, to 250 feet from the left tower. And again, if we want to write this in an interval, we figure out our starting point. So it's starting at 0. We have all of the x values, because again, it's increasing, decreasing, goes for the x values as the x's are going to the right until we reach that 250. So our inequalities will say all of the x values that are bigger than 0, so it needs to be facing like this, but then all of the x values that are smaller than 250. So all the x values bigger than 0, but smaller than 250. That is the interval of which it is decreasing. So to describe the domain of the function, again, remember, recall that the domain are the x values. So the x values, we look at this x value. We have a graph on here. So we do have an x value of 0. We have all of these x values at 50, 75, 100, 101, all of those values, and it keeps going. All of these x values are still happening. And then it comes to a stop right here at the x value of 500. So the domain starts at, the domain is the x values. The domain starts at 0, the x value of 0, but then it stops at 500. And then our intervals are the same as what we've done earlier. We want to say that it's all the x values that are bigger than or equal to 0, but then all of our x values are smaller than or equal to 500. If we want to describe the range is the y values. So we want to find the first y value that the graph actually hits. So if I use a sheet of paper for this, if this is the y value of 0 where my paper is now, I want to hit my first y value. So if I move it up, it actually hits at right there, which is roughly a little bit above 20, so maybe 25. Maybe 25. I'd probably go with about 25. And then it's going to keep going up. All of these y values, you see how the graph is, I'm hitting the graph with the yellow piece of paper. It's going to keep going up. It's going to keep going up until it finally stops here. Because if I kept going up, I wouldn't hit any more graph. And that's at about, again, 150, because that was the y-intercept. So the range is the y values. And that first y value was about 25, and then it went up to about 150. So our inequality, we'll say all the y values that are bigger than 25, so it's got to be open towards the y, equal to, because it does hit that 25, and then it's going to be smaller than, but it does hit the 150, so it's going to be less than or equal to 150, and that is the range of the function.